Hello students, today we will discuss the PN junction diode used as a solar cell. Now solar cell is very common nowadays. With the help of solar energy we are producing the electrical energy. So solar cell main purpose is that using the solar energy we can produce the electrical energy because solar energy is very cheap. The cheap means in that sense that is no cost. So with the help of the sunlight we can produce the electricity, but this solar cell is also made up from the PN junction. So our topic today, that is the PN junction as the solar cell. Now let me give some idea what is the solar cell, how we make this one. Actually solar cell is a PN junction diode. This figure shows this one, but the difference is that here the N crystal is very thin and P crystal is very thick. This is the difference. And see, this P type, on the top of the P type we place one metal type finger type, this type metal sheet and connected with a lead, and lower portion there is a metal sheet and connection wire is there. So this is the simple construction. With some model I can show this one. Suppose we make in this way. This is one P type crystal. Okay, on this P type crystal now we will use one N type crystal which should be thin one. Suppose this is the N type crystal. So let us place the N type crystal and P type crystal. They are placed in this way, side by side. Okay. After that what we will do, we have to take the connection. That means when they will produce the voltage anyway, I will see how they will produce the voltage. Then the voltage from P type we have to take it out, and from N type also we have to bring it out. Now how we will bring it out? On the lower portion, that means with the P type, we place one metal plate, just like one metal plate you place in this way. So metal connection is there. We can get one lead from the metal lower portion, but upper portion we don't place one solid metal plate, but instead of solid metal plate what we place this type one metal finger type things, finger type metal sheet, and we place it on this one, so that the lead in the lower portion it can get from the metal plate from the P type, and from N type we can get the connection with this type of finger type of metal sheet. This is the finger type. Now the question is why we are using the finger type? Because on the N type we will focus the sun rays. So sun rays should enter inside the PN junction. So when the sun rays will enter, we have to give some space. So if I place one metal sheet like this, sun rays will not enter. So instead of this, we are using this type of metal finger type things, metal finger, which will give you the connection from the N section. And just to protect it, you can place one glass plate on it. So this is the one formation of a simple model of your solar cell. So just see once, thick P type, thin N type crystal, and all from the connection of N type we use this type of metal finger, and for the connection from the P type we use one metal plate like this, and then we place one glass sheet so that it will not break, and then we place it on the sunlight like this. So the board which you have seen everywhere as a solar panel, this is the basic function of a solar panel. Now come to the point how this solar panel will act and you will get the energy from the sunlight. Okay, so this is the function. So this is the P and N type, and always P is the very thin, and you have seen the thickness of the P type is nearly 300 micrometer type, and N type this thickness comes nearly equal to 0.3 micrometer. So easily you can understand how much thick and how much thin N type and P type is. Okay, so this is the very thin, this is the thick one, and metal connections are already connected there, so that we can get the connection from this section. Okay, after that, now we'll come to the function. We know that when the P and N type are connected, so remember there is no battery, but we will use it as a battery, is it? Okay, when this one comes, P and N type close together, we know the question of depletion layer will come. Yes, N type free electron will come to the holes. These electrons, all the electrons, they will occupy the space of the holes. In this way, all the free electron of the N type, they will come to occupy the place of the holes in the P type. As a result, they will recombine, and due to the recombination, we know that in between this portion there will be a section. They will cancel each other, means they will recombine. Cancel, better word is recombination. They will recombine, and there will be no free charges. Yes, there will be no free charges. Electron will be cancelled by the holes in this section, and this is called the depletion layer. We know that this is the depletion layer, and this depletion layer will be created here also, just like the previous lecture. Okay, so this is our depletion layer. Automatically when there will be depletion layer, we know that in between these two there will be Voltage also, yes. Why? Because the electrons are moving away from here, so automatic one positive potential will be created in this section. And as the electrons are coming to occupy the space of the hole, the electrons are coming, so this side will be negative. In this way, from positive to negative, we can get one electric field like this. Electric field will act from positive to negative. This thing already we know in the different section of other photodiode and other thing. This is very similar to photodiode. Photodiode we use the battery to run the circuit in reverse bias, but here there is no battery. Okay, so this is the combination, the depletion layer will be created. Okay, now come to the point. After that, what we will do? Now we will focus the sunlight. That will it will place in on the upper surface of the roof or somewhere else. So when the sun rays are coming, we know that these are the nothing but the photon, E equal to h nu photon. See, now this is the way when we don't use the solid metal plate on the top of the N type. We use this type finger type so that this photon particle can enter inside the junction through this gap and it will come here. Okay. After coming to this point, the function is very similar to photodiode. When these photons will enter inside this portion, then what will happen? We know that now this space there is no free charge, but there is silicon atoms. Silicon crystals are there. So from the silicon crystal, suppose one silicon atom, only one I am showing. Silicon atom, 4 electrons are there. So let me show it here. This will get enough space. So here is the silicon atom. 4 electrons are there. Okay. Now, when this photon particle will hit the silicon, just like photodiode, what they will do? They will bring out these photoelectron from the outer shell. These electron will come out because these photoelectron will hit the silicon atom, an atomic valence electron in the outer shell. They will now come out. They are not free electron. They become free electron now. After getting the heat from the photon particle, these electrons will come out. Now, when these electrons will come out, what will happen? See, this section already got one barrier potential, positive this side, negative this side. So this barrier potential positive, they will just simply attract this electron this side. So automatically electrons will come to N direction. Automatically this electron concentration will be more in the N type now gradually. Because one by one silicon atom, they will emit the electron, outer shell electron due to this photon heating. And for this reason, so many electrons will come out, but now the electrons, where they will go, there is no battery connection. So what they will do, due to this barrier potential, positive potential, they will be attracted that side. So electrons will go that side. Now the question, when the electrons will go that side, what will happen? The electrons, those who came here to occupy the space of the hole, these electrons will move to occupy the space of these electrons. So when they will go that side, automatically hole will be created. So what happens? Electrons are moving along this direction and holes are moving in downward direction. In this way, we can see due to the action of this photon particle, the electron from silicon atom, they will come out and the electrons concentration in the N type will be more. At the same time, the concentration of hole in the P type will be more. Okay. Now, if it is connected, these electron will come here and they will get the touch of the metal plate. So from the metal plate, through this metal plate, there will be a negative potential created here. And the holes are connected with the metal sheet. So these holes will give you a positive potential here. In this way, we can get one negative and positive potential. So it behaves just like a battery. Very clear? Very close relationship with the photodiode. So up to this much photodiode theory acts, because the silicon atom, they emit the electron, but in photodiode, by using the battery, we pass the current in this way. But in this particular case, as there is no battery connection, so these free electron will be attracted by this barrier potential to the N side and the holes in the opposite direction. So electron concentration more means there will be a negative voltage, and here one positive voltage will be created, and we can use it as a battery. So this is called the solar cell. It acts in this way. Now let me give some idea about the voltage and current like here. Suppose when this voltage will be created, no current will pass as there is no connection. So in this particular position, that we get the voltage. Yes, voltage is there in between the two pole. It is open circuit now. We call this is the open circuit. So now it is open circuit. Open circuit. So in open circuit, we can get the voltage. But what about the current? Current is equal to 0 because no current is passing. So in graph, if I show in this way, this is the voltage. So when the current is 0, this current is equal to 0, then we get the voltage. So this is the voltage OC, means open circuit voltage. We get the voltage like here. Okay. Okay, now we'll just short this circuit by a wire. Connect a wire in between these two. So when we connect these two by a wire, we are making it short circuit. This is called the short circuit. So when we make the short circuit, now what will happen? Now the current will pass very fast. Current will move very fast. That means now this will change. Now the current will be maximum. I will be maximum. So when the I will be maximum, current will be maximum, what will be the position of the EMF or voltage? We know one relationship. If you forget, you will get in Ohm's law again, that EMF E equal to V minus I into R. This type relation we will get. E is the EMF, V is the voltage, current and resistance in this way. So when it shows that the I is maximum in short circuit, so when the I is the maximum one, automatically V will be nearly equal to 0. So automatically when I is maximum, V comes to 0. Is it clear? Because now I is maximum, so when negative part is the maximum, it means that it is maximum means this V should be nearly equal to 0, so that it comes the constant value E. So to give constant value E, when the I will increase a large extent, V should become down and nearly equal to 0. So in this case, when current is maximum, voltage is equal to 0. So in current axis, this is our current axis. Suppose this is the maximum current. When the maximum current, now see the voltage comes to 0. So the two position we have shown, that when the open circuit, it was the open circuit, then we got the voltage but no current. So no current, we get the voltage. But in closed circuit, not closed, better to say short circuit, in this position we have seen that the current will be maximum, then the voltage will be 0. So current is maximum, then the voltage comes to 0. In this way we get the graph. So this current we call the ISC, means the I short circuit current. Okay. So the graph should come like this with the dotted line I have shown. This will be the fashion of the graph. What does it mean? It means that as the voltage will be more, see, when the voltage is suppose here, when the voltage will be more, current is small. Now increase the current. See, current is increasing, voltage is decreasing. Current is increasing, voltage is decreasing. So this is the relation. Current is increasing and the voltage is decreasing. So graph we can get like this. So this is very important for board exam, the graphical representation of the solar cell. Okay. So in short, just the highlights is that there will be a P-type and N-type semiconductor. N-type is very thin, P-type is the thick one. On N-type, there will be a metal connection in lower portion, but lower portion is flat metal sheet, but in the upper portion we use one finger type metal sheet like this. After that, when you focus this one, we know that there will be a depletion region automatically. So when this photon particle will enter in the depletion region, there is no free charge, but there is silicon atom. So they will hit the silicon atom. When they hit the silicon atom, then the electron from the outer shell will come out. So where this electron will go, there is a barrier potential positive, so they will be attracted towards the N-type. Automatically holes will be attracted in the P-type. In this way, if the process continues, that means the sun rays are coming, continuously silicon atoms are breaking up and they are emitting the electron continuously, then the concentration of electron in the N-type will be more and concentration of hole in the P-type will be more, which create a negative voltage on through this metal finger plate, and the positive potential from the metal plate we can get it here. Okay, so this is the function how the solar cell works. And regarding the graph also I have shown, when it was open we get the voltage but no current. So we get the voltage, see the current is 0. Okay, this is current axis, current is 0, voltage is maximum. And reverse one, when you make a short circuit like this with the connection, then when the short circuit, then I is maximum because current is getting the path. So when the current is maximum, V comes to 0 because according to this relation. So when the current is maximum, V comes to 0. Now one point you may ask, sir, when the current is passing, why you are showing current to negative side? Yes, this is the question. Current may come to this side also. Why not here? Current. This is the current axis. Point is that when you connect in this, then you see the current will pass from positive to negative side, then from this side, then from N-type to P-type. So when the current is coming from N-type to P-type, this is the reverse bias. Because normally it goes from here positive to negative, and from P-type to N-type, this is the forward direction. Now the reverse direction current is passing in this case. Particularly, this is the speciality that as the current passes from positive to negative, so inside the PN junction, what happened? Current is passing from N-type to P-type. So this is the reverse connection. So reverse connection means that we got the negative current and we got the graph like this dotted line. This line shows that when current is small, then the voltage is also decreasing. You increase the current, see the voltage is decreasing. You increase more current, then the voltage is decreasing, current is maximum, voltage comes to 0. So this is the graphical presentation of the solar cell. Okay, so this is about your solar cell. What solar panel you can see somewhere, then you can see one board, so many white lines are there. What are these white lines? White lines is nothing but this type of metal fingers. The metal fingers are there, because if we block it, sun rays cannot enter. So this blockage you can get this type. If you see on a solar panel, this type board, so many lines are there. So what are these lines? These lines are nothing but the metal finger. These from the N type, their connection is there, and there is a big thick type P-type crystal. From the P-type, another section is coming out. Now these two will produce the voltage, and if it is connected with a battery, so in daytime they will charge the battery continuously, and during night that battery will supply the light. So the solar light, what you see in the forest area or somewhere else, during night time you can get the light, because daytime these type of solar cells are present and they will charge a battery. That battery will run the light during the night, and this is only one single cell. In this way, so many blocks when placed on a board, it becomes a solar panel. This is one small section of a solar cell. This type several solar cells are placed in series connection. After that, you can get a huge voltage from this one. Okay, so this is the use of a PN junction as the solar cell. Okay, I think the semiconductor portion in CBSE class 12, this is the last chapter, last section which you have to discuss. So this is about the solar cell. Now see all the videos what I have given to your YouTube. You can just share these also, and if you do this one, then you can get the idea about the different type of use of the PN junction. That will because if you go to the higher study in your engineering level or in BSc course, these are given. It is not too much elaborately explained in CBSE, but I have done for your future purpose, so that in future also you can get some idea. In daily life, someone can ask you as a science student how the solar cells are working, so that if your idea is clear, at least you can give some idea. They may ask LED, what is LED? So if you have seen my video, you can get the idea, and then you can give some idea. So at least the people will understand, okay, the student knows about the what is LED, what is solar cell, what is photodiode. This should be known. These are very commonly used materials in daily life, and you should know as a science student, you should have to know what is the basic theory inside it. Very interesting one: depletion layer, barrier potential, then breakup of silicon atom to bring out the electrons. This section, if these ideas are clear to you, easily you can explain to someone else. Okay, so best of luck. Let me finish this one. Thank you.